Okay, boys, so we're going to do some examples now. A lot more examples anyway. So number 2, count the number of possible outcomes and state whether each outcome is equally likely. So make sure you read the whole question. So we're looking at tossing a coin. So rather than just count the possible outcomes, I'd like you to write down what those outcomes are first. So on a coin you could get heads or tails. Then you can count them, that's 2. So we have 2 possible outcomes. Now, if you think about those outcomes, yes, they are equally likely because there's only 2 things on a coin, heads and tails. Heads has 1 out of 2 chance of occurring and tails has 1 out of 2 chance of occurring. So they are the same fractions, so yes, they are equally likely. In part B, we have the result of a rugby match between Australia and New Zealand. So, the things that could happen, Australia could win, New Zealand could win, or they could have a draw. So the number of possible outcomes are 3. Are they equally likely? No, not at all. Okay, so there's a lot of things that come into this. A draw, as we know, rarely happens. And Australia winning and New Zealand winning, well, that really depends on a lot of other things. It's not a game of luck. It's not a game of chance. It all depends on how good the 2 teams are at the time they play. So injuries come into it, the ability of the players, sometimes a bit of luck on the field. So in no way are these 3 outcomes equally likely. Okay, number 3. This time they want you to list the outcomes in each event. So that's all we're doing, listing them. The first one says selecting a vowel from the letters of the alphabet. The vowel's the key thing here. We're looking at the whole 26 letters in the alphabet. And the vowels are A, E, I, O, U. So that's all you have to do. Just list the vowels. In the second one, having a house number greater than 4 but less than 10. So greater than means you can't include it. So we can't include the 4. So we're starting at 5. That's the first number greater than 4. 5, 6, 7, 8 and 9, and we're stopping there because the number has to be less than 10. It can't include the 10. So they're all the possible things you could have. That's your list of outcomes. Alright, now number 4, these questions are normally really badly done in exams. Okay, a number of reasons for it is because you've got numbers all over the place here. Some of the numbers are the number of coins, and some of the numbers are actually the value on the coin itself. Okay, so we have 4 $2 coins. So it's only 4 coins there, but they're $2 coins. Then we have 3 coins that are $1 coins. We have 2 coins that are 50-cent pieces. We have 6 coins that are 20-cent coins. And we have 5 coins that are 10-cent coins. So we shake the money box, 1 falls out. We're disregarding the fact that some of the coins are bigger, some of them way more. We're not looking at that. Just pretend they're all the same. Okay, so we're calculating the probability that the coin that falls out is a 50-cent coin. So I've circled all the numbers of coins. So we've got 4 coins, 3 coins, 2 coins, 6 coins and 5 coins. If you total all of those up, we have 20 coins altogether. So that will be the number on the bottom, the total number of coins. We want to know how many of those 20 coins are 50-cent coins. And they told you there were 2 of them. So 2 out of the 20 coins are 50-cent coins. Simplify it on your fraction key and you'll get 1 over 10. Next one, we're doing the probability of a dollar coin coming out. So we look at the dollar coins and we have 3 of them. So we have 3 $1 coins out of a total of 20 coins. Now this question says answer is a decimal. So we're not leaving it as a fraction this time. They want a decimal. So we're going to use the SD key on the calculator to change it to 0.15, and there's your decimal answer. All right, the next one, the probability of a 10-cent or 20-cent coin as a percentage. Now, if you see the word or, it's always a plus. If you remember that, it will help you even when you get to year 11 and 12. Or means we add. So we're going to add together the number of 10-cent coins and the number of 20-cent coins. So up here it tells you we've got 5 10-cent coins and 6 20-cent coins. We're going to add those two together because we could have a 10 or a 20 for this question coming out. And on the bottom we have 20 coins altogether. To make it a percentage, we times by 100. Now, you don't need to do that next line. If you want to go straight from there to the answer, you can. You can just put that straight in your calculator as it stands if you want to. And your final answer will be 55. And remember, it is a percentage, so put your percent sign on the end. Okay, the next one up the top here. We want the probability that it's not a 10-cent coin. So we could go, all right, well, we don't want the 10-cent coins, we want all the others. So I'm going to add up 4, 3, 2, and 6. But not these because they're 10-cent coins. So if we add all those up, we're going to get 15 coins out of 20 coins, which simplifies to 3 over 4. But if you're clever about it, you go, okay, well, I don't want a 10-cent coin. So really, I've got the whole 20 coins, but let's just get rid of the ones that are 10 cents. So we could do on the top 20, take off the 10-cent coins, and that'll still have a 15 on the top for you, and you'll still get the same answer. All right, the next one, the probability of a gold coin as a decimal. So you can see how important it is to read these questions. There's a lot in them. A gold coin. You know from all the fundraising days we have, you bring in a gold coin, you bring in a $1 coin, or you bring in a $2 coin. They're the only gold coins we have. So we need to add up the $1 and the $2 coins. Well, we have 3 $1 coins, and we have 4 $2 coins. So we're going to add those together on the top, out of a total of 20 coins. And don't forget, after you put this in your calculator and press equals, use your SD key to get that answer to a decimal like they wanted. And the last one here, we want a probability of a coin under $1 as a percentage. So the coins under $1 value are the 50 cents, the 20 cents, and the 10 cents. So we're going to add up these numbers of coins, 2, 6, and 5. And put that on the top, out of your total 20 coins. And then make it a percentage by timesing by 100. If you put that all in your calculator, you'll get an answer of 65, and don't forget the percent sign. So we're going to come back in a third video and just do a few more examples on this.